Exercises 4C and D, the language of polynomials. So today we're learning about various polynomials. What you need to be able to do is recognize features of various polynomials, find a factor using the remainder theorem, use long division to factorize a cubic, factorize the quotient using quadratic concepts, and use the null factor law to find the x-intercepts. So to start off with, and this is the 4C part, it's really just about the language of polynomials. So going through each of these dot points, a polynomial is a function that can be written in this particular form. I know that looks super confusing, but what that's really trying to say is that we've got some sort of coefficient here, and x is to the power of a number. The next one also has another coefficient, but x is one less in the power. And you will keep going until you end up with just a constant. So an example of this could just simply be 2x cubed plus 3x minus 1. And you can see that my powers are going down. In this case, my x squared power has a 0 coefficient because I can't see it there until I reach a constant there. We call the term that has the highest power the leading term, and the degree of the polynomial will be whatever that number is. So if the highest power is x to the power of 4, then that's the leading term, and then the index of that particular polynomial is to the power of 4. That's what we would call a quartic. A monic polynomial is a polynomial whose leading term has a coefficient of 1, so that we just don't see a number in front of that highest power. Now, moving on to 4D, we are going to talk about the long division of polynomials. So the purpose of this is to be able to factorize it, and of course we want to factorize it in order to be able to find the x-intercepts. So you would have done this in year 11 as well, but just as a little bit of a revision, this is how we long divide, and I'm going to go through a couple of examples to remind you. There are some key parts. So there's something called the divisor. That's going to be what I'm dividing it into, or rather the thing that I'm dividing my polynomial by. Then I've got the actual polynomial itself. So that's what I'm dividing the divisor into. We've got the quotient. So that's kind of like the answer, how many times something goes into something else. And then we sometimes end up with a remainder as well. And a lot of the times we want our remainder to end up as 0. So the easiest way, in my opinion, to explain this is to go back to grade 4 and to kind of think about long division with just normal numbers. So I'm just going to quickly go through an example. So if I want to do 40 divided by 3, how many times does 3 go into 40? So the first thing I would do is think of 3 goes into 4 one time. Now I want to think about, okay, well, how many times does that happen? So 1 times 3 is just 3. Okay, so that's multiplying that quotient, or what's how many times it goes into, by 3. And then what we do is we actually subtract these. So 4 minus 3 is 1. Then what I'll do is I'll add that 0 again. And then I do the process again. Now I'm going to do it for both numbers because I've put that 0 down. So 3 goes into 10 3 times. 3 times 3 is 9. Subtract, and then I'll have 1 left over. Now, in this case, 3 can't go into 1, so in that case, that would be my remainder. So just to kind of break down all the different things that I did, the first thing was that I actually divided. Like I said 3 into 4, how many times is that? So that's division. The second thing was I multiplied to see how many lots I have. The third thing is I subtracted, and then the fourth thing was that I added a new number. So that's one way of thinking of the process. So divide, times, subtract, plus. So these are your 4 steps. Now, in terms of what we actually get out of this, so we have 40 as our polynomial, and this whole process allows us to write our polynomial in a different way. So the way we can write 40 is the quotient. So how many times 3 has gone into it? That's 13. The divisor plus 1. And so if we think about it, 13 times 3 is 39, plus 1 is 40. So that's one way I can rewrite my polynomial once I've long divided. Now, doing it with polynomials is a little bit more complicated because we don't really think of it as how many times does 2x plus 6 go into 6x squared. Rather, we're just going to consider one term at a time. So let's go ahead and practice this with our first example over here. So we'll have divide 3x to the power of 4 minus 9x squared plus 27x minus 8 by x minus 2. The first thing I want to point out here is that we're actually missing a term. Might not seem like a big deal now, but once you go ahead and actually start dividing, you're going to notice that there's an issue. So what we do is that if there is a power that is missing, so in this case to the power of 3, we're going to add it in, but as a 0. So 3x to the power of 4 plus 0x cubed minus 9x squared plus 27x minus 8. And we're just going to go ahead and divide that by x minus 2. All right, now remember the 3 processes, or the 4 processes rather. So first we divide, then we multiply, then we subtract, and then we add. All right. And when we're doing it by polynomials, we just do it one term at a time. So the first thing I'm thinking of is how many times does x go into 3x to the power of 4? And the other way to think about it is x times what will give me this number? I think that's the easiest way to consider it. So we will need 3x, and we will need 3 more x's there because that's to the power of 4. That's step one. Next, we're going to multiply. So 3x cubed times x gives me 3x to the power of 4, and that's great. I always want these two to match. Now, this is where we use our next term. We are going to go ahead and multiply it by the next term as well, because the whole thing is what I'm trying to divide by. So 3x cubed times negative 2 is going to give me negative 6x squared. Sorry, to the power of 3. Now, this, hopefully you can see, is why I needed that extra term of 3, because now I need to subtract them. If I didn't have that, then it wouldn't match up. All right, now we're up to step 3, where we're going to go ahead and subtract them. So the first term should hopefully always be 0. If it's not, then you've done it incorrectly. Then we'll have 0x cubed minus minus, so plus 6x cubed. So we'll end up with positive 6x cubed. Now, our final step here is to add the next term. So I'm just going to bring that down. It's not too far down. So that will be, well, actually, it's a little bit further. It'll be here. All right, and now we're just going to go ahead and repeat the process. So x goes into 6x cubed, or rather think of it as how much more do I need? I need 6x squared. So my pen goes a little bit funny sometimes. All right, 6x squared times x is going to be 6x cubed. Wrong spot. Make sure you line it up nicely, unlike I just did. And then 6x squared times negative 2 is going to give me negative 12x squared. Now we can go ahead and subtract. So that's step 3. The first one gives me a 0. Negative 9x squared minus minus. So we're talking about a plus. That's going to be 3x squared, positive 3x squared. And then our final step is to go ahead and add. So I'm going to go ahead and add the next term now. I keep stopping it one step too early. So beautiful. Let's repeat x into 3x squared, 3x, 3x squared. Multiply it. 3x times negative 2 is going to be negative 6x. Subtract 27 minus minus, so that'll be a plus, 33x. And then final step, we bring down the negative 8. All right, I've run out of space a little bit. Let me just shuffle things around. Last one. X goes into 33x 33 times. 33 times x is 33x, and then 33 times negative 2 will be negative 66. Negative 8 plus 66 will be 58. So I'll just run out of space there again. Let me resize this. So that will be 58 there. All right, and we can't really do much else because we need x's to be able to multiply it. So this is what we have as our remainder. So if we were to break down the different parts of what I've got here, this is what I call my divisor. This is what I call my polynomial. This is what I call my quotient. And this is what I call my remainder. Okay, so there's a couple of ways that we can write this if required. So we can either write it as the polynomial divided by the divisor, and that is going to essentially be your quotient plus the remainder. And then, as you saw in the previous example, we can also write it as the quotient multiplied by the divisor plus the remainder. Okay, so that's how we divide. Hopefully that has jogged your memory from last year. So let's get into things a little bit more technical. Now, the one thing you'll notice is they actually told us what to divide by, but a lot of the time you need to figure that out yourself. So we have this thing called the remainder theorem. Instead of having to constantly divide, asking ourselves, trying out x minus 1, will that work? X minus 2, will that work? And having to do this whole process, which will take way too long to get a remainder of 0. because of course, if it gets a remainder of 0, then that means that it's a factor. We want to be able to test it out quickly. So the remainder theorem is when we have a polynomial divided by ax plus b, the remainder will be p negative b on a. So all this is really the solution of that. So if this is my factor, 2x plus 1, if I make that equal to 0, then I'll have my solution as negative 1/2. So that's all that's really saying here. So what we're trying to say is I can actually figure out what the remainder of this just by substituting in x is equal to negative 1/2. So we're going to go ahead and do that. Now, it's not very nice when we have fractions and powers, but we just got to deal with it. Okay, so let's give this one a go. So to the power of 3, that will be negative 8. To the power of 2, half to the power of 2 is a quarter, positive quarter, because it's squared, and then times 3. So that'll be 3/4. Then we'll have positive 5 on 2, and then we will have 7. Now, lots of ways to do this. I think the easiest way is just to make it all on a denominator of 8. So I'm just going to multiply everything through by whatever I need to do to make it on a denominator of 8. So we'll end up with negative 1/8 plus 6 on 8 plus 20 on 8 plus 56 on 8. And then when you add that all up, you should get 81 on 8. So obviously that is not a remainder of 0, which means x equals negative 1/2 is not a solution. Okay, so the factor theorem, the idea of this is that if I do get a remainder of 0, then it is a factor. Because if you think about it, if you were to substitute in y is equal to something, y is equal to a number, whatever it is, if I sub that into a polynomial and I get a solution, or not y equals rather, sorry, x equals a number, x equals 2. If I get y is equal to 0, that means that's an intercept. So that's what we're talking about over here, a factor. So here says, show that that x plus 1 is a factor of that, and hence find the other factors. So we'll do this one step at a time. So the first thing that we want to do is to show that. So the solution would be if I take 1 to the other side, that's negative 1. And to show that it's a factor, it means that when I substitute in negative 1, I expect to receive a 0. So let's go ahead and test that theory out. That will be negative 1, and then that will be minus 4, minus 1, plus 6. So minus 1 minus 4 is negative 5, minus another 1 is negative 6, plus 6 will be 0. Hence, x plus 1 is a factor. Now, the second part says, hence, find the other factors. In order to do that, we will use long division. Now that I know what one of the factors is, I can factorize it. I'm just going to go ahead and do that just in the part B section, because this is the part where it says factorize. So there's a little bit more to it, but we'll do the long division here, and then we'll fully factorize it from there. So we know that x plus 1 is a factor, as we just tested it out. And we're going to put our polynomial in here. Now, I'm going to go a little bit faster than I did before. If you need, feel free to pause the video at any time. So x will go into x cubed, x squared times, multiply that out, subtract. So negative 4 minus 1 is going to be negative 5x squared. Bring the next number down. That'll be negative 5x to go into negative 5x squared. Negative 5x times x will be negative 5x squared minus 5x. Subtract those. So the first one's 0, and then x minus minus, which remember is a plus. So that should be 6x. Bring down the 6. Now 6x, or x into 6x is just 6. So that'll be 6x plus 6, and it very nicely ends up being a 0, which is wonderful. Okay, so that's my long division there. So what that tells me is that my polynomial can be rewritten as the divisor multiplied by the quotient. Now, it's asked me to factorize it. As you can see, this part is factorized, but this part is not. So what we now have to do is go ahead and factorize that. However, that's just a quadratic, so that should be very straightforward. Two numbers that multiply to give us 6, to give us negative 5 will be negative 3 and negative 2. So my polynomial factorized will be x plus 1, x minus 3, and x minus 2. All right, now the next one, example 17. So it says this function has a factor of this, and when f of x is divided by that, the remainder is 15. Calculate the values of a and b. So there's a bit of information here. The first one is that the factor x, it has a factor of x plus 3. That means that when I substitute in the solution of -3, I should get a remainder of 0. And then the next one is that when it's divided by this, the remainder is 15. So that means when I sub in the solution of 2, I should get a y value of 15. So I've now gone ahead and gotten 2 points. I can simply substitute them in and be able to find my factors from there. So let's go ahead and make two equations here. So that will be 0 is equal to 2x cubed plus, sorry, I should sub in the x as well. So that'll be 2 times -3 cubed plus, where are we up to? -3 squared minus b times -3 plus 3. If we were to simplify that, or rather just expand that out, we should get this. And then I like to get all the numbers on one side and all the letters on the other. So if I put that all together, I'll get 51 is equal to 9a plus 3b. Simplify it if you can. I'm going to divide everything by 3 there. So that will be 17 is equal to 3a plus b. It's my first equation. All right, let's do the same with our second. So that was for 1. Now let's do 2, same thing. So 15 is equal to 2. Now every time I see an x, I'm going to sub in a 2. Okay, expand that all out. So that'll be 16 plus 4a minus 2b plus 3. All the numbers on one side, all the letters on the other. So that'll be -4 is equal to 4a minus 2b. And I can see I can divide everything by 2. Okay, so there's my second equation there. Now all I need to do is solve this simultaneously. So I've got 17 is equal to 3a plus b, and I've got -2 is equal to 2a minus b. So if I've got that as equation 1 and equation 2, what I'm going to do is I'm going to do equation 1 plus, plus equation 2, because b plus minus b will just be 0, and that's the idea. I want to be able to eliminate one of the variables. So if I add the two together, so that'll be 17 plus -2, so that'll just be 15. 3a plus 2a is 5a, and then of course b plus minus b is just 0. Therefore a should equal to 3. From there, I can go ahead and substitute that into any equation. I'm probably just going to sub it into 2 because that's just a lot easier, smaller numbers. -2 is equal to 2 times 3 minus b. So that'll be -2 is equal to 6 minus b. If I take the b over and the 2 over, so that'll be b is equal to 6 plus 2, which is 8. And there are my solutions. So a is equal to 3, b is equal to 8. Now, of course, you can also do this on the CAS calculator as well. So it just really depends what the question is asking you. On the CAS, the first thing I would do is define the function itself. Make sure you put a times in between everything. We will then solve system of equations, and our two unknowns are a and b. And all you have to do is substitute in, like you'd go f1 of -3 equals 0, and f1 of 2 is equal to 15. You would substitute that in. Then once you get it, you should get your two answers of a equals 3 and b is equal to 8. So practice that on your CAS as well. All right, let's continue from there. So example 17, it says this particular function has an factor x plus 3 when f of x is divided by that. Oh, sorry, it's the same question. It then just says find the other two factors of f of x. So we already know one of the factors is x plus 3. We also know from the previous question that a is equal to, I think that was 3, and b is equal to 8. So we can go ahead and substitute those values in and do our long division once again. Might be worth at this point just pausing the video and giving the long division a shot for it by yourself. Okay. So that's my two equations. I'm now going to go through the process. So x goes into that 2x squared. Multiply that out. That'll be 6x squared. So that should be a cubed. Subtract that, that'll give you -3x squared. Bring the next one down. So then that'll be -3x So minus minus will be plus, so we've got negative 8 plus 9. So that's just going to end up being positive x. So then that'll be 1. And then, sorry, I'm going to bring that down as well. Multiply that out very nicely. I get a wonderful 0. So once again, my polynomial is equal to the divisor multiplied by the quotient. All right, now I can go ahead and factorize that. Now this is a non-monic quadratic, so I'm going to need to do our AC method. So 2 times 1, so I need two numbers that multiply to 2 and two numbers that will add to negative 3. So that'll probably be negative 2x and x. So in terms of writing this out, so that'll be 2x squared and then a plus 1. And then I'm just going to go ahead and split this into two terms. So that'll be negative 2x minus x. Now I can go ahead and factorize by grouping. So that's 2x, x minus 1. I'll pull the negative out, x minus 1. I'll pull the common factor out, which is x minus 1, and then what's left over is 2x minus 1. And of course, this just comes down as well. There you go. So that there is fully factorized. All right, we're going to stop the video there as part 1. So this is the long division. Come back for the second video where we talk about cubics.